Now we're going to look at a same track separation scenario. So here we have two overflying aircraft. We have Sierra Echo India Tango Alpha overflying TMA from Ulis to Deya to Pedder at flight level 70. And we also have Sierra Echo Golf November Lima also flying from Ulis to Deya to Pedder, also at flight level 70, of course. But as you can see, Sierra November Lima, they call us first at Ulis at time 58, a good half hour before Sierra Tango Alpha. But they are much slower. An IFR Cherokee doing 90 knots, that's only 1.5 miles a minute. It's going to take a long time. And as you can see by the strip, it's actually going to take 51 minutes for that aircraft to cross our TMA. So something here has to change, so we need to find another solution. So, as always, when you get your strips, you need to work out a picture in your head of what the traffic situation looks like. In this case, it's nice and easy. Both aircraft inbound from the northwest at Ulis, overflying Deya, and then outbound to the southeast, outbound to Pedder. So, what are our options? Now, in this case, we're looking at same track separations. So, our same track separations, we have 10-minute separation. We can also have 20-mile separation, and then of course we also have lateral separation as another option, and at some point in time we're going to need to use vertical separation. The 10-minute separation, which we'll go through shortly, that does work, but as you can see by the times, there is going to be a point in time where this 10-minute separation does not work, and we'll talk about how we will figure out where that is and when to provide vertical separation. Again, the 20-mile separation, at the start we have 20 miles between the aircraft, but the aircraft are getting closer and closer together, so we need to come up with another solution there, and we need to work out where that would occur. Okay, so what we'll do, just to help get the picture into your mind, is we're going to look at the timings between these aircraft and try and work out where the 10-minute separation exists, and where the 10-minute separation ceases to exist. So here we have a nice diagram with the Cherokee first, Sierra November Lima is overhead Ulis, and Sierra Tango Alpha is quite some distance behind. So, first thing to think about, what is the time separation when Sierra November Lima is at Ulis? So when we look at the time separation, we're talking about how long does it take for the second aircraft to get to the point where that first aircraft was. So when Sierra November Lima is at Ulis, they are there at time 58. Sierra Tango Alpha is estimating to be there at time 29. So there is 31 minutes between those two estimates, which means that there is 31 minutes of separation between these aircraft. That is saying it's going to take Sierra Tango Alpha 31 minutes to fly to where Sierra November Lima was, which is Ulis. Let's look at Deya next. What is the time separation at Deya? Again, we're looking at when the first aircraft is there and how long it takes for that second aircraft to get there. In this case, Sierra November Lima is crossing Deya at time 23, and Sierra Tango Alpha is estimating to cross Deya at time 40. So now we have 17 minutes between the aircraft. So our 10-minute separation still exists. We actually have 17 minutes, so we actually have even some buffer. Now let's look at the Pedder time. What is the time separation at Pedder? Well, as you can see by the diagram, they're closing right up now, and then you look at the strips. Sierra November Lima is crossing Pedder at time 49, and Sierra Tango Alpha's estimate for Pedder is time 52. So there's only 3 minutes between these two aircraft now. So a 10-minute separation no longer exists. Now, we need to provide a separation after the 10-minute separation no longer exists. So for me, if I was wanting to be lazy, I would say I have 10-minute separation when Sierra November Lima is at Ulis. I have 10-minute separation when Sierra November Lima is at Deya, and it does not exist when Sierra November Lima is at Pedder. So the last point in time that I know that it exists is when Sierra November Lima is at Deya. So what we can do is we can get Sierra Tango Alpha to be vertically separated by the time that Sierra November Lima crosses Deya, because remember, we know that the 10-minute separation exists at Deya, so we are moving from a 10-minute separation into a vertical separation. Now the problem with this separation is that Sierra November Lima is going to be Deya at time 2-3. Where is Sierra Tango Alpha going to be at time 2-3? They're not even going to be inside our TMA yet. They're actually still 6 minutes away from Ulyss. But if we're going to provide the 10-minute separation, one easy way to say is we would obviously contact the previous sector, sector 1, and say requirement for Sierra Tango Alpha to be vertically separated, so 8-0 or 6-0 or 9-0 by time 2-3. And then we have ensured that that 10-minute separation exists. What we have seen though is that we actually have 17 minutes at Deya, and that's nearly double the separation that we require. We know that we have 3 minutes at Peta, so there is a point somewhere in between here where the 10-minute separation is exactly that. It is 10 minutes separation. So we want to try and figure out where the aircraft are and what is the time when the 10-minute separation exists. Again, this is, well, the easy option is to do it at Deya because we know that exists. This does take a little bit of calculation, and depending on your traffic load, this could take up too much of your time and you might want to use a different solution. But there is a point in time where the aircraft gets so close that Sierra November Lima is at a point in space that Sierra Tango Alpha is going to take 10 minutes to fly to that same point. And we want to try and work out for practice purposes where this point is. The answer is actually time 3-5, but then the question is, how do we actually get to time 3-5 in the first place? What we're going to do is we need to look at the rate of closing between the two aircraft. The rate of closing is how closer Sierra Tango Alpha is getting to Sierra November Lima every minute, and we're going to measure it in nautical miles per minute. If we look at their flight plans, we can see that Sierra November Lima is flying at 90 knots. That is 1.5 nautical miles per minute. And we can see that Sierra Tango Alpha is flying at 210 knots. Now the difference between them is 120 knots, and we know that 120 knots is 2 nautical miles per minute. So what we're saying here is that every minute that goes by, Sierra Tango Alpha is actually getting 2 minutes closer to Sierra November Lima. At time 2-3, that is when Sierra November Lima is at Deya. We have 17 minutes between them, and that means that we have 7 minutes of actual extra separation because we only need 10 minutes between them. So the extra distance is that 7 minutes of extra time that we have times the full speed of Sierra Tango Alpha. And again, we go back to Sierra Tango Alpha's speed is 210 knots. So that is 3.5 nautical miles per minute. If you divide it by 60, 1 mile per minute, you get 3.5 nautical miles per minute. So 7 times 3.5 is 24.5 nautical miles. So what we're saying here is that the extra, we have 7 minutes of extra time between them, and if we convert that extra time to extra distance, we have 24.5 nautical miles between these two aircraft. So we know we have 24.5 nautical miles extra. Now we want to divide that by the rate of closing. We already know that the rate of closing is 2 nautical miles per minute. So what we're saying here is 24.5 divided by 2 is 12 minutes. It's 12.25, but we'll say it's 12 minutes. 12 minutes, it's going to take 12 minutes for Sierra Tango Alpha to fly that extra distance and then be only 10 minutes flying time between the aircraft. So now we know it's going to take them 12 minutes. It's going to take them 12 minutes to close the extra 7 minutes. And remember, it's in this scenario, we've based it on Sierra November Lima's Deya time. So the Deya time is at time 2-3. We add the extra 12 minutes, and then we have time 3-5. So now we know at time 3-5, Sierra November Lima is halfway between Dea and Peta, or thereabouts, and also at time 3-5, Sierra Tango Alpha is somewhere between Ulus and Dea. They're 5 minutes away from Dea. But wherever Sierra November Lima is at time 3-5, it's going to take Sierra Tango Alpha 10 minutes to get to that same point in time. So we know that the 10-minute separation exists at that point in time. However, of course, at time 3-6, that separation no longer exists. So 3-5 is our limit, so we need to do something by then. So we need to establish vertical separation by time 3-5. So in this case, we have elected to climb Sierra Tango Alpha. Sierra Tango Alpha climbed to flight level 90, cross flight level 80 by time 3-5 or earlier. Of course, we don't mind if they get there by 3-5, or we don't mind if they get there at time 3-4 or 3-3, as long as they are 80 or above by time 3-5. And now we have ensured that we have 10 minutes vertical separation between these two aircraft. Here's the same track scenario where we have two aircraft, and thankfully they're nicely vertically separated. So we have Sierra November Lima is overflying at flight level 60 from Peta to Dea to Ulus, and we have Sierra Tango Alpha also overflying from Peta to Dea to Ulus, but thankfully they are at flight level 80. However, of course, because we want to practice this, Dea Control, Sierra Tango Alpha, request descent to flight level 60, of course. So we need to ensure some kind of separation between these two aircraft. First of all, we will look at where the aircraft are actually going, so you need to build your mental picture. In this case, it's nice and simple. They're both arriving inbound via Peta to the southeast, overflying Dea, and then outbound via Ulus. So what are our options? So we need to think about what are our same track and same level separations, because at the end of the day, these aircraft are going to be flying at the same level. So we have 10 minutes, but if Sierra Tango Alpha is in front, because it is a faster aircraft, we also have the option of using 5-minute 20-knot separation and even 3-minute 40-knot separation. If we're using the distance separations, we can use 20 nautical miles, but again, if Sierra Tango Alpha is in front, there can be, we know that 20 knots or more faster, so we can use 10 nautical mile 20-knot separation. As always, lateral separation is always an option. And then vertical separation. Vertical separation, we have vertical separation now, and in this case we're going to transfer from vertical separation to another form of separation to try and allow Sierra Tango Alpha to descend to flight level 60. Some initial questions that we want to look at is who's actually the first aircraft? We don't know where Sierra Tango Alpha makes the request to flight level 60, so we'll leave this one out yet. But first of all, let's think about who is actually the first aircraft. At Peta, it's actually Sierra November Lima, because Sierra November Lima crosses Peta at time 49, and Sierra Tango Alpha, the faster aircraft, crosses Peta at time 03. Let's look at Dea though. Sierra Tango Alpha crosses Dea at time 14, 1 minute ahead of Sierra November Lima. So what we actually have here is Sierra November Lima entering the TMA first, and then being overtaken by Sierra Tango Alpha just before Dea. And then of course, as the aircraft are outbound towards Ulus, then the times are going to get bigger and the distance between the two aircraft is going to get bigger as well. So that pass occurs just before Dea. Who is the fastest aircraft? Well, we've just been talking about that. It's Sierra Tango Alpha. We can see their flight plan there at 210 knots, 3.5 nautical miles per minute. And Sierra November Lima is flight planned at 90 knots, around about 1.5 nautical miles per minute. So let's look at another way of envisaging what these aircraft are doing. So we have Sierra November Lima crossing Peta. What is the time separation between these two aircraft? Well, we saw that Sierra November Lima is there at time 49, and Sierra Tango Alpha is going to be there at time 03. So we have 14 minutes flying time between these two aircraft. What about when they get to Dea? Well, when they get to Dea, Sierra Tango Alpha, remember, has just overflown Sierra November Lima, and they cross at time 14. So the first time when we looked at the separation between Peta, we were basing it on Sierra November Lima's time. Sierra November Lima crossed at 49er, and we said it's going to take Sierra Tango Alpha 14 minutes to fly to that same point in airspace. However, because Sierra Tango Alpha has now overtaken Sierra November Lima, we now take Sierra Tango Alpha's Daya time. So they crossed Daya at 1:04. Sierra November Lima is going to cross at 1:05, which means there is 1 minute flying time. That is, it's going to take Sierra November Lima 1 minute to fly to that point in airspace where Sierra Tango Alpha just was. And then if we look at Ulis, the distances and the time has got a lot larger between them. Sierra Tango Alpha crossed Ulis at time 2:05, and Sierra November Lima is estimating at time 4:01, so we now have 16 minutes. Now, depending on how you want to run this, one option is to say, okay, if we are going to apply a 3 minute and 40 knot separation, we don't have the 3 minutes at Daya, but we do have 3 minutes at Ulis. So the lazy controller could say, at Ulis, descend to flight level 60, because we know at Ulis you have that 3 minute separation between the aircraft. However, we have 16 minutes, so it's much more time than we actually need. So there is a point in time where that 3 minutes will actually occur somewhere else. So when does the 3 minute separation actually occur? It occurs at time 1:06, but then of course the question is, how do we work that out? In this case, we're going to look at the rate of opening between these two aircraft. So when we look at Sierra, to use the 3 minute 40 knot separation, Sierra Tango Alpha has to be in front because it has to be the faster aircraft. And Sierra Tango Alpha is flying at 3.5 nautical miles per minute, 210 knots. Sierra November Lima is flying 1.5 nautical miles between them, 90 knots. So there's 120 knots difference between them. So 2 nautical miles per minute is the rate of opening. So what we're saying there is every minute Sierra Tango Alpha is 2 nautical miles further in front of Sierra November Lima. So after 10 minutes, Sierra Tango Alpha would be 20 nautical miles ahead of Sierra November Lima relative to where they were 10 minutes ago. At time 1:04, there are 2 minutes missing from what we need to apply a 3 minute 40 knot separation. So at time 1:04, Sierra Tango Alpha is at Daya. Sierra November Lima is 1 minute flying time away. So we need 2 more minutes between the aircraft. The extra distance required at time 1:04 is 3 nautical miles. And we can work this out by saying, okay, the speed of Sierra November Lima is 90 knots. It's 1.5 nautical miles per minute. And we need an extra 2 minutes of flying time. So if we convert that 2 minutes of flying time into a distance, it's 2 minutes times the 1.5 nautical miles per minute is 3 nautical miles. So we need an extra 3 nautical miles between these two aircraft. How long is it going to take us to actually get that extra 3 nautical miles? Well, we know that the rate of opening is 2 nautical miles per minute. So 3 divided by 2, even air traffic controllers can work that out, it's 1.5 minutes. So it's going to take 1.5 extra minutes from time 1:04. So we'll round that up to 2 minutes to make it nice and safe. And then, so at time 1:04 plus the extra 2 minutes is time 1:06. So now we can tell Sierra Tango Alpha at time 1:06 descend to flight level 60. Or we just wait until time 1:06 and then descend Sierra Tango Alpha to flight level 60. Other alternatives we have was the distance 10 and 20 nautical miles. So in this case we would ask the aircraft for distance reports, and we would keep asking for distance reports until Sierra Tango Alpha is 10 nautical miles in front of Sierra November Lima. Remembering before that the rate of opening is 2 nautical miles per minute, so if we assume they cross around about Daya, it's going to be about 5 minutes after the Daya time, maybe 4 or 5 minutes after Sierra Tango Alpha crosses Daya. So actually in this scenario, the 3 minutes 40 knot separation was the most efficient separation to use. We could also use lateral separation. It is an option. Again, it's not the best option, but what we could do is send Sierra Tango Alpha outbound on radial 306 instead of radial 2901, establish both aircraft on the radials. Sierra Tango Alpha gets to distance 15, they're now laterally separated, and Sierra Tango Alpha can descend. But of course they're overflying. He wants to go via Ulis, and we're sending them off track via radial 306. So it's not the most efficient option in this case.